What's up, guys? If you have been having issue understanding lipogenesis or TAG synthesis, or you have been studying it and you seem to not understand it, stay throughout the course of this video because I'll be breaking down in more simple ways so that when time you read it again, you understand it. And again, if you are new to my channel, make sure to subscribe. Please, I want you to subscribe so that when I drop any, and turn on your post notification button so that when I drop any video, you'll be sure to be notified. If you have any topics that you seem to not understand and you want a video to be made for you on those topics, just write it on the comment section. If I go to the comment section, I'll make the video for you. So let us dive into the video. We'll be talking about triacylglycerol formation or lipogenesis using the following outline. We'll introduce them, we'll write the factors that stimulate and inhibit them, we'll talk about the biological pathway, we'll talk about the regulation, and we'll talk about the clinical correlation. So stick throughout the course of this video because I'll be explaining it with this following outline: the introduction, factors that stimulate and inhibit, the biological pathway, the regulation, and one or two clinical correlation. So let us begin with the introduction. First of all, we'll be introducing what lipogenesis is. What is lipogenesis? Lipogenesis is a metabolic processes which involves the what? Acetylation of what? Fatty acid to form what? Triacylglycerol. So when you acetylate fatty acid, you get TAG or triacylglycerol. What is triacylglycerol? Triacylglycerol is what major storage of fat in animal and human. So our fat is stored in the adipocyte and the liver as what? TAG. So now when you have 3 moles of fatty acid, 3 moles of fatty acid or 3 moles of fatty acyl-CoA is what esterified with what they call glycerol backbone to form what? TAG. So we are storing every fatty food we eat or every carbohydrate food we eat sometimes are stored as fat in the liver and in the adipocyte. So this is very important because a high amount of lipid is stored and the carbohydrate part is stored in case for a long time. So in case we are fasting or we are having a constant strenuous exercise in which we need it, then we now start breaking them down to form what? ATP. So lipogenesis is good because we store fat and fat later is used for what? Energy. What are the factors that stimulate and inhibit lipogenesis or TAG formation? What are the factors that stimulate? The factors that stimulate is a high wet fat state. When you eat a high rich carbohydrate and lipid food, it enhances or it stimulates lipolysis or TAG formation. And also an increased insulin to glucagon ratio also stimulates what? Lipogenesis very well. And what are the factors that inhibit? The factors that inhibit is what? A decrease in insulin to glucagon ratio, fasting, starvation, high strenuous exercise. All this what? Inhibits what? Lipogenesis or TAG formation. Also an increase in cortisol level also inhibit lipogenesis. So hope you have understand the factors that stimulate, which is a high fat, well-fed state, which is increase in what? Carbohydrate and lipid food, to increase in insulin to glucagon ratio. Both of them stimulate. While a decrease in insulin to glucagon ratio, fasting, starvation, and high strenuous exercise with an increase in cortisol level inhibit what? Lipogenesis. Next we'll be talking about is the biochemical pathway for what? Lipogenesis or TAG synthesis. So the question is, how are they formed in the cell of the adipocyte and the liver? First of all, you have to form 2 things, which is glycerol 3-phosphate from glycolysis, and again you have to what? Form fatty acyl-CoA from the what? Acetylation of acetyl-CoA to what? Fatty acid. So when acetyl-CoA transferred by transferase enzyme to fatty acid, it will form fatty acyl-CoA by acyl-CoA transferase. So acyl-CoA transferase transfers acetyl-CoA to fatty acid. Why the hydrogen acetone phosphate is being reduced to form what? Glycerol 3-phosphate by glycerol 3-phosphate dehydrogenase. Don't forget, dihydrogen acetone phosphate is reduced to what? Glycerol 3-phosphate by glycerol 3-phosphate dehydrogenase. Why acetyl-CoA is being transferred to fatty acid by what? Acyl-CoA what? Transferase. Don't forget. So now we have fatty acyl-CoA, especially 3 moles of fatty acyl-CoA and what? Glycerol 3-phosphate. So the second is to what? Transfer this what? The fatty acid from the fatty acyl-CoA to each carbon 1, carbon 2, carbon 3 of what? Glycerol 3-phosphate. So how do we do this? So number one, we will transfer the first fatty acid from fatty acyl-CoA to the carbon 1 of the glycerol 3-phosphate. So if we transfer the first fatty acid from fatty acid CoA to the carbon one, what are we going to get? We'll get what? Lysophosphatidic acid. Lysophosphatidic acid. By the enzyme what? G3-PAT. What is G3-PAT? Glycerol 3-phosphate acyl transferase. That is the enzyme. The second one will transfer the what? Second fatty acid from the second fatty acid CoA to what? Lysophosphatidic acid to get what? Phosphatidic acid. By the enzyme what? Acyl glycerol 3-phosphate acyl transferase, AG3-PAT. Acyl glycerol 3-phosphate acyl transferase. Now the next one is that you cannot transfer the last fatty acid to what? Glycerol 3-phosphate, the last on the carbon 3. No, you have to remove the phosphate first. And how are we going to remove the phosphate? We will use what? PAP, PAP, phosphatidic acid phosphatase. We will use phosphatidic acid phosphatase. We will remove the last phosphate there. So if we remove the last phosphate, what will be forming? We'll be forming DAG. So now we have formed DAG. Now we can transfer the last fatty acid from the last fatty acid CoA to carbon 3 of DAG to form what? TAG. By DAG acyl transferase. So it's very simple. Don't forget, it's very simple. We form DAG, and when we form DAG, what do? We now transfer the last fatty acid from the last fatty acid CoA to carbon 3 of DAG to form what? Triacylglycerol. By the enzyme DAG acyl transferase. How can you regulate lipogenesis or TAG synthesis? First of all, is the dietary intake. Like we discussed in factor stimulating. A food rich in lipid or carbohydrate stimulate or promote what? Lipogenesis or TAG synthesis. But when you don't eat during fasting or starvation, it inhibits lipogenesis but favors what? Lipolysis. Very simple. The next one is hormones. Insulin is used more. Insulin is stimulated when there is intake of food, because the more the insulin, the more the uptake of what? Glucose. And when you have glucose favors glycolysis, which favors what? Lipogenesis. But when you start stimulating glucagon inhibits lipogenesis but stimulate what? Lipolysis. Very, very important. Allosterically, you can also promote lipogenesis by doing what? Increasing the formation of glycerol 3-phosphate and what? Fatty acid CoA. So when you are increasing especially when you stimulate high hexokinase, which is used in glycolytic pathway, the first step in glycolytic pathway. So when you are stimulating or you are increasing hexokinase, you are also favoring lipogenesis. When you are increasing what? Phosphofructokinase, so you are also stimulating what? Lipogenesis allosterically. And also when you are increasing what? Acetyl-CoA formation for acetylation of what? Fatty acid, you are also stimulating what? Lipogenesis. But most of these, if you want to inhibit them, you have to just decrease the amount of what? Glycerol 3-phosphate formation. When you are decreasing glycerol 3-phosphate formation, you are inhibiting lipogenesis but stimulating what? Lipolysis. Because in lipolysis, you are breaking down this what? TAG to form what? 3 moles of fatty acid and what? Glycerol. I hope it all makes sense and you understand what lipogenesis is in just this short video. Hope it all makes sense to you, and if you go back to study, it will be much more easier for you to study. If you have any question, please drop it down in the comment section, and if you are just new to my video, make sure to subscribe and turn on your post notification button so that when I drop any video, you should be sure to you'll be notified anytime. So thank you for joining us in this biochemical series. I will see you in the next class. Thank you.